So today is day 2 with our multivariate linear systems and row operations. And so these are the ones that we have to figure out, okay, maybe using that inverse matrix option didn't work because my determinant was 0, so I did not have an inverse to solve it. And so with that, I have to have some other options to solve without having to go through all that pain and time you had to take back in Algebra 2. So we're going to use that other tab we talked about yesterday. And so remember, this is when I need to have a matrix set up that's going to have the square part first. So that would be 5, -1, 1 and 1, and then the 10 and 3. But instead of having it in 2 separate matrices and a variable matrices with it, I'm going to have it all at once, all together. So let's go and find out what are some of the things I'm allowed to do with these matrices. So first off, one thing I'm allowed to do is I'm allowed to switch 2 rows. And so we'll look at what that looks like with the matrix we just wrote in a second. And then we can also multiply a row by any number I want to, as long as it is a non-zero real number. So I can multiply it by a fraction, a whole number, a decimal, positive, negative, doesn't matter as long as it's not 0. So then my third one, I can add 2 rows together like we did with elimination in order to simplify things out. And so these are used to actually transform into row echelon form or even reduced row echelon, which is the even better version. And so to do that, first off, we need to find out what do these 1, 2, 3 steps look like when I do them. So first off, one step said I'm allowed to switch 2 rows. So if I wanted to, I can rewrite this matrix as 1, 1, 3, 5, -1, 10. In this case, there was no benefit to actually switching the order, but sometimes there is, and so we want to use that to our advantage when switching it does make sense. So you are allowed to switch it, and they're equivalent. It also mentioned I'm allowed to multiply a whole row by a number. So what if I want to multiply row 2 by 2, just because I can. So if I want to multiply row 2 by 2, my row 1 stays the same. And so my second row would become 2 times 1 is 2, 2 times 1 is 2, 2 times 3 is 6. And so this matrix, even though it looks different, is still equivalent. And so I could have divided, that still works. So another option we have is to go in and instead of just multiplying by 1 row, I can actually go in and strategically use it to simplify in terms of trying to solve. So what I want us to do is I'm going to keep row 1 the same, but let's keep row 1 the same. And so I'm going to have row 1 minus 5 row 2. And I'm going to put it in place of row 2. You could put it in place of row 1 if you wanted to, but you do keep one of the rows the same when you go to change the other one. So what does this mean? So row 1 is 5, -1, 10. And so I'm going to subtract multiplying that second row by 5. So that would be a -5, -5, and a -15. Well, now that I distributed that negative, I can add them. So that gives me a 0, -6, -5. So in place of row 2, I'm actually going to write that simplification down instead. That gives me a 0, a -6, and a -5. What this does is now I just got rid of x in that second row. So I know it seemed kind of random that I chose that value. In your homework when you're doing these operations, it tells you what rows to add or subtract or multiply by. You don't have to guess today. I'm going to leave all the guesswork up to our calculators when I show you how to use them to simplify. So getting that 0 there is actually one step in what's called row echelon. Because what I want to happen is I want 1s on that diagonal I just drew in green, and then I want 0s in that bottom. I'm going to call it a triangle because if I have more than 2 rows, it does form a triangle in that bottom section. So let's go look at I don't know why it keeps doing 3 of those. So my reduced row echelon form, and what that means. So it means the rows consisting of zeros, we're going to always push those to the bottom. So we'll rearrange them if any rows of 0 show up. And then the first row that would show up on any one should be a 1 if it's a non-zero number. And those, we really want them to occur on the diagonal. We want the one that shows up in that row 1, entry 1 spot. We want that to be the first row. And if it shows up on row 2, second entry, we want that one on the second row. And then that's all that bottom part mentions is how they should increase. So to help make this sense, I want to show you an example of a linear system that's already in row echelon, and you'll see why it's helpful. So to get started, the system that is currently on the board is, if we go to write it in our 1 matrix, that would give me 1, -2, 1, 7, 0, because I did not have an x, -2, no, not -2, 1, then a -2, and then a -7, and then 0, 0, 1, 3. So as I mentioned, it has 1 on that diagonal of my square part of the matrix. And then down in the bottom, I have a triangle of zeros. So why is that helpful? Well, if you look back at our equations, if I can use all those row properties by adding them together, switching them around, multiplying them by a number, and maybe multiplying and adding them to a number, that's going to allow me to get it into this system. And notice, we like when z is equal to 3, because then I can plug 3 in to find what y is, and then I'll know y, and I know z, so I can plug them both into that first one. So it puts me in a really good place to find the actual solution. So I'm going to walk you through finding row echelon form for 1, 3 by 4 matrix in steps. And then I'm going to show you how to do it on your calculator, because I'm not going to ask you to do it step by step yourself, because it would be a lot of guesswork to do it without that. So here is my system of equations. And so on this screen, I've already turned this system into a matrix for us. And so we're going to use that to go in and solve it. So it takes a lot of work to go in and get all of those done. And it's really just being really careful about making sure you don't end up making a small algebra mistake, which would throw the whole matrix off if you're using one mistake over and over and over again in the next future steps. I'm just showing you the basics of this. Realistically, I'm going to have your calculator do this tonight when you have to solve the whole system. So let's go ahead. This is not all of the steps, but this is a good bit of them. So first of all, I'm going to take my beautiful matrix here. And so this notation says I'm going to switch row 2 and row 1. The reason they did that is they wanted this 1 in that first spot, because that's going to make it easy for me to use that row to cancel out in the other 2 rows to get the zeros that I wanted. So the next thing I'm going to aim for is I'm going to aim for a 0 where that 2 is I just circled. So to do that, I'm going to multiply row 1 by a -2 and add it to row 2. What that does when I go in and add it, it gets me that 0 I wanted. So right now I have 1, 0. I still need a 1 there, 0, 0, and a 1. So it's going to take some time. So the next one I'm going to aim for is I'm going to aim for that 3. I'm still going to use that row 1. So I'm going to multiply row 1 by -3. And then I'm going to add row 3 to it, because 3 plus a -3 is 0. And so this gets me that first column that I want to have in that reduced row echelon. So my next goal is to get a 1 here. To do that, I'm just going to divide that row by 13. Yes, we get fractions. Yes, they're not pretty. I claim it will get better. So when I replace that, divide that whole row by 13, so the whole entire row 2 gets divided by 13. So when I do that, you can now see that I have the 1, 0, 0, 1. And so, well, to get rid of that 14, because that's the next 0 I need to go in and multiply row 2 by a negative 14. That'll help it cancel out. That's why we like getting those 1s first, because then we can use that row where there's a 1 to get rid of it. So by doing that and adding it to row 2, I have my 1, 0, 1, 0, 0 that I wanted to have. But what's still wrong? Well, I want a big fat 1 right here. So in order to get that, I will divide that row by the negative 31 over 13 or multiply by the reciprocal, which in this case gets me a 1 and a 1. But so the ones I cared about were on this main diagonal, and then I wanted a triangle of zeros. Because now, hey, I actually do know what z is, because this means z equals 1. The equation above it means y plus 5 over 13z equals negative 21 over 13. That negative didn't show up. And then that top row means x minus 5y minus 3z equals 10. So now it's in that setup in which I can plug this z value in to the previous two equations. Once I find y, I can also plug y into that first one, and I can find all three of my variables easily. So by doing so, when I convert it, I find out that y is negative. I find out that y is negative 2. I already had z was 1. By plugging negative 2 and my 1 in down here, I end up getting my coordinate value is 3, negative 2, 1. So there's an even better way to do this instead of using that reduced row echelon. Using just row echelon. But before I do that, I want to show you how to do it in your calculator. And we'll do both of them at the same time in our calculator so that we can see what it looks like. So here's my calculator. I have to turn it on. And let me go into second matrix. I don't remember what my A is at this current moment, so I'm going to need to edit it. And so 2, 3, negative 1. It looks like it might already have typed this matrix in. So I have 2, 3, negative 1, negative 1. And then I have negative 1, 5, 3, negative 10, 3, negative 1, 6, 5. So this way will probably not seem as easy on paper as the other one did, but this one takes a little less work for you to go do it. So on my calculator, I'm going to get out of there. I'm going to clear my home screen, which was whatever I did last from yesterday's homework assignment. So I'm going to hit second matrix. And I'm actually going to arrow over to the math option. And then I want you to... I just realized you can't see the screen. Hold on. There you go. So I've already typed in my matrix, and I'm going to arrow down, and I'm going to come down until I see A, and it says REF beside it, which stands for it's row echelon form. So if you hit enter on A, on your home screen, you'd see REF in a parentheses. So I'm going to insert my matrix A in there, and I'm going to hit enter. So I don't like it in that format, so I'm going to go ahead and do math frac, because I hate getting decimals in them. I'm going to hit enter. And so this did give me that entry that I had earlier. This one has more fractions in it, and that's okay. It's just because of the way that this one solved it. It looks like they switched some different rows from what we had switched. Okay. But reduced row echelon, what it does is it has, I'm going to move the calculator, we'll come back to it in a second. And so it has some other requirements for us. So reduced row echelon wants me to have ones and zeros everywhere in that first little rectangle. my square by square matrix. What that's going to allow me to do is using reduced row echelon form, instead of just using row echelon form, it's going to simplify that matrix a little bit more for me. So what I'm going to do on my calculator is, we're going to use an example so you can see it. I'm going to do second matrix math, arrow over to math, and then scroll down to one past row echelon form. There's an RREF, which is reduced row echelon form. If you hit enter on that one, and then type in your matrix A, and then hit enter with it, it'll give you your reduced row echelon form. And that is the exact same answer I had earlier. It just gave it to me all at once. And so I'm going to write this matrix down on a screen for us, because I know, it actually is staying. But I'm going to go ahead and show it to us. So this is my matrix 1, 0, 0, 3, 0, 1, 0, negative 2, 0, 0, 1, 1. So what they did is that square matrix at the beginning, it got the identity matrix right there. So that has all my 1s and 0s in it. But what that does, remember, this is my x, this is y, and this is z. So it's now simplified my equations to x equals 3, y equals negative 2, and z equals 1. So sometimes my reduced row echelon form can't simplify it completely down, which means maybe there'd be like a 1, 1 here, or maybe there would be a row of zeros and some extra ones where we have zeros, and that's because that's my no solution or my infinite solution. Things have gone a little crazy for us. And so, but those take care of themselves. So for example, if you did reduced row echelon form and you have 1, 0, 1, 7, 0, 1, 1, 5, 0, 0, 0, 0. What this means is I have x plus z equals 7, and I have y plus z equals 5. And that was because I had a z equals z. My z's canceled out somewhere. Z is all real numbers. And then the x and y's that go along with z's all real numbers. And so that's an infinite solution situation. So when you have a row of zeros, that's your infinite solutions. So let me know if you have any questions, comments, concerns. We can do this with another one. And so let's go in and look. So this is the one we did yesterday using the other system. And so if I wanted to use reduced row echelon, actually I think this is the one we just solved, isn't it? I don't know. Is it? Let me pull up my calculator. I don't remember. What is my matrix A? This is the one we just did. So we are already good to go. So let me know if you have any questions, comments, concerns on how do you type these in your calculator, how do you solve them. You can do this with 4 variables, which would mean you have a 4 by 5. Take your time with them. Double check your matrices are typed in correctly to your calculator when you do them, because if you don't type them in correctly, that's usually where the errors are going to come from when using reduced row echelon. Use reduced row echelon to solve, because it'll make it a lot faster on the ones you have to do that with. Let me know if you need anything. I'll talk to you guys later. Have a good day. Bye.